Hi there, so I'm Andy and I've got this pretty cool cardboard hovercraft here. It is just cardboard, it's kind of a piece of junk for now. It's still definitely a work in progress. I'm working on perfecting it. But it's pretty simple actually. It's just got this cardboard frame here. It's got this 3D printed shroud within which is this 9 by 4.5 inch propeller powered by just a standard brushless drone motor. And then I've got this tail fin in the back. This keeps it flying straight because it is essentially flying. It's hovering above the ground. There's very little friction. So without this fin, if I went to try to turn, it's very easy to get it to just start spinning in circles. That was an issue I was having, so I added this tail fin. So essentially when it's flying, this thing sort of drags behind it, and if any little deflection in the direction of motion causes this thing to drag against the air, and it pushes it back straight, so that's nice. And I've got these two 8-inch propellers up on the front, powered by two more just standard brushless drone motors, controlled by this Arduino right here. It's a little Arduino Nano hooked up to three just standard 20 amp ESCs that control the motors. Then I got this joystick here. It's aluminum. Nobody else has an aluminum joystick. It's pretty fantastic. I made it, not because I had to, but just because it's pretty awesome to have an aluminum joystick. I hope you agree. And the communication between the joystick and the hovercraft is just with these little Series 1 XBs right here and over here. So it's all pretty straightforward. You can see in here, the air just gets forced down into this chamber in here, and then it comes out along the edges down here. And this is essentially how a full-scale hovercraft works. And the principle is that it creates this current of air, or curtain. It's actually described as a curtain, I believe. This curtain of high-pressure air shooting out around the bottom edge. And that, of course, pushes it up off the ground, but it also, some of that high-pressure air gets trapped underneath here, and it actually gets sort of trapped behind that curtain. And that makes the hovering mechanism of a hovercraft actually much more efficient for this very low hovering than you could achieve with the same motors, the same batteries, for just a helicopter, say, or a drone. Actually, this is very interesting. I was doing some testing with this propeller and this shroud last year for a school project, and this propeller right here can actually only achieve about 8 newtons of thrust, actually, whereas this whole hovercraft right here with the batteries on it, this thing weighs about 18 newtons. So I'm getting way more out of this thing than I would if I were just trying to suspend this thing from like a propeller, right? If I had this thing sitting way up here and I was just trying to lift itself up, that wouldn't work. But with this mechanism down here, with this hovercraft mechanism, it actually does work. So that's pretty cool. So I've got a few videos of me testing it out the other day. It's obviously pretty hard to control, but it's not impossible, and it is pretty fun to mess around with. So I'll definitely be working on trying to make it easier to control, but here it is.